Hey folks, this is section 5.4 function notation, and it is our continuation into the unit 5 function unit, and it's called function notation. So let's get started. Now, if you're looking for this in your current book, you're gonna run into problems finding it. It's actually in the purple book, which we'll be handing out to you at a later date. So I would focus on the notes, and we'll supplement the assignments with worksheets as we go forward through this section. Now, function notation is a fairly simple concept, but and you want to really open your mind to making it simple for yourself. Okay, so let's just start with our daily objective. I can evaluate, solve, and graph functions in function notation. Okay, function notation. So basically I clipped this out of the book. And as I mentioned, the book is the purple book, which we'll be diving into within the next couple months here. Towards the end of the year, we'll be really diving into it. But let's just jump right into what function notation really means. So in section 5.3, you learn that you can write a linear function in the form of y is equal to mx plus b. So we've been working with slope intercept now since the beginning of the year. By naming a linear function f, you can also write the function using what is called function notation. So if you take a look at what I am putting a circle around here versus what is down here, basically what's happened is the y is now this little f and a parentheses, this x and another parentheses, okay? So basically the y is replaced with this what's called function notation, okay? So how you say this is f at x, okay? So f at x equals mx plus b, all right? So the notation fx is another name for y. So f at x is another name for y. If f is a function and x is in its domain, then f at x represents the output of f corresponding to the input x. Okay, so basically if you have a simple equation and you're going to evaluate it at f at 1, that x would be 1, so it'd be f at 1 would equal whatever m times 1 plus b. So you can use letters other than f to name a function such as g or h. So most of the common ones are f at x, g of x, or h of x. And it replaces the y. So the y is gone. There's no y is equal to mx plus b. But with function notation, we have this thing called f at x. Okay, and primarily you're going to see the f. All right, let's take a look at example 1. A lot of this is going to come fairly quickly to you because you're going to say, well, we've done this before, and it's really true. So basically what we're asking you to do here with this number 1 is to evaluate f at x equals negative 4x plus 7, okay? Evaluate f at x equals negative 4x plus 7 when x equals 2. Okay, so what we're going to do is we're going to put in place of that x, we're going to put a 2. Okay, so you see how I just took the 2 and I placed it in there. Now we're not multiplying anything. This is just it's a notation. It's replaces the y. So you want to think of it as just like a label on something. So it tells you a little bit about the function. We're evaluating it at the value of x equals to 2. Okay, so now what we're going to do is we're going to take that 2 and we're going to substitute it into our function. Okay, not an equation. Notice I stopped and corrected myself. So wherever I saw the x now, I'm going to place the 2. okay, just like I have it on the left side. So what that is now, that's equal to -4 times 2, or -8, plus 7 equals -1. So what's the difference here? We don't have a y, all right? So the y is gone. We have this thing called function notation, but basically this process of substituting a value for x into the function is the same as what we have been doing before. Okay, so that should come pretty quickly to you in the following examples. Let's look at example 2. Oh, we have 3 on your own. Okay, so we're going to evaluate these 2 problems. F at x equals -2x minus 5. We're going to evaluate the function for f at -4. Okay, we will do that one. We're also going to evaluate the function at f at 0. And we're going to evaluate the function at f at 3. So I'm just going to move that down a little bit. F at 3. Okay, so we're going to evaluate the function at those 3 values of x. Okay. All right, so then we go ahead. We're going to substitute in for x -4. So we go 2 times a -4. And then subtract 5, okay? So down here, I'll go 2 times 0, and then I'm going to subtract 5. F at 3, I'm going to have 2. Now I'm going to place 3 there, and then I'm going to subtract 5. Okay, sometimes it's easy to see how this is just a substitution, but it's just the function notation replaces the y. And so let's go ahead and just solve this. 2 times -4 is -8, minus 5 equals -13. And that would be your answer for that one. 2 times 0 is 0, minus 5 would equal -5. 2 times 3 is 6, minus 5 is 1. 6 minus 5 equals 1. So what you just did there is you evaluated the function of x, which is 2x minus 5. You evaluated when f at x is -4, f is at 0, and f is at 3. Okay, so this is function notation, and it all it simply does is it replaces the y. You can see none of the y is around. Let's do another one. G of x is equal to the negative of x minus 1. Okay, so let's go ahead and evaluate g at -4. Okay, so what I'm going to do here is I'm going to take the negative of a -4. Then I will subtract 1. So the negative of a -4 is equal to 4. Subtract 1, and your answer to g as -4 is equal to 3. The second x is f at g at 0. So again, we're just going to place your g at 0. Notice the function changed from an f to a g, and you said that the most common ones would be f at x, g of x, h of x. I've seen k of x, but those 3 are the main ones. So g at x, g at 0 equals the negative of 0 minus 1, which is equal to -1. And the third, g at 3, g at 3. So wherever we see 3 as x, we'll place it in to take the negative of 3 and then subtract 1, and that would be a -4. Function notation, and that will be evaluating a function. That's the first types of problems that you're going to be looking at doing in this section. Moving on to the second example, solving for the independent variable. All right, so what we're going to be doing here is we're going to take the h of x is equal to 2/3 times x minus 5. Find the value of x for which the function h of x equals -7. Okay, so this is identifying the idea that we're looking for the function's value at a -7. So you see where this is h of x here? We're instead of given x, we're given the function value of a -7. Okay, so right underneath the h of x, I will place the -7. -7 equals 2/3 of x minus a 5. Okay, now we're looking for the value of x that makes that true. So this is just a matter of solving for x. Add 5. Okay, add 5 and add 5 to both sides to isolate that variable. -7 plus 5 is -2. And that's equal to 2/3 times x. Okay. Now we have a fraction and we're solving, so we want to think of our reciprocal. So we want to think of our reciprocal to help us here. Our reciprocal of 2/3 is 3/2 on the right and 3/2 on the left. Now this is -2/1. Okay, so as you remember that. So the reciprocal is your friend here, and it kind of eliminates the fraction. Cancels, cancel, cancel, and cancel, and cancel, and all you have is left is your x is 3 times a -2, which is -6, divided by 2, which is equal to -3, for example 2. So what's the difference here? Instead of given the value of x to place into our function, we are given the value of the function, and then we found the value of x. In this case, our value of x was -3. -3. Okay, that brings us to our next two on your owns, numbers 3 and 4. Find the value of x so that the function has the given value. Okay, let's take a look at those two. Find the value of x so that the function has the given value. All right, so again, we're going to start out by substituting in for f at x, which is 21. Okay, so 21 will be the f at x. 21 will be placed right underneath the f at x is equal to 6x plus 9. Okay, so this is a matter of solving for x now. Subtract 9. And you get 6x equals 12. Divide by 6. X equals 2. So where f of x equals 21, your answer then would, so f at 2 would equal 21 for number 3. You could either have either as an answer. The book has just x equals 2. And number 4 on your own. See, this g of x is -1. So I'm going to switch colors. I'll switch back to black here. Okay. So g of x is -1. So I'm just going to place right underneath where the g of x is. We'll put our -1. And that's equal to the -1/2 times x plus 3. Okay. And then we go ahead and solve. Subtract 3. Subtract 3. And we'd have -1 minus 3 is -4. That's equal to the -1/2 x. And here's that fraction again. And we're looking to solve for x by the use of the reciprocal. So the reciprocal will be, in this case, -2/1. Multiply the left, and -2/1. Multiply the left and the right, I should say, or right and left, and your answer is 8. X equals 8 on number 4. In the last example today, because that's function notation. This is kind of like you're given the x the first example, and you found the value of the function. The second example, you're given the value of the function, and you found the x, kind of in reverse. All right. So hopefully those examples will help you with the homework that's ahead of you. Okay, the last part of this lesson is graphing. Okay, so this is going to be another review on graphing. Remember, I was telling you about how the book will introduce graphing early, and then we continually reteach graphing because, well, basically this class is all about slope and intercept and understanding the coordinate plane. And that's pretty much what Algebra 1 is. And so that's why here we go with function notation with graphing. All right, example 3, pretty simple question. Graph the f at x is equal to 2x plus 5. Okay, now you know how to graph, and you know how to graph a certain way. Now, with function notation, it's quite easy to resort to just pick a few points. Okay, so like f at 0, 2 times 0 plus 5 is 5. So your coordinate plane would be 0, 5, 0, positive 5. F at 1 is equal to 2 times 1, which is 2, plus 5 is 7. So in this first one was 0, 5. The second one is at 1, 7. Remember, the x is the first coordinate, left to right, 1, 7 all the way up. And you could take another point just to verify your first two, -1. And you have 2 times -1 is a -2, add 5. -2 plus 5 is 3. So that would be -1 was x, positive 3 is the function f at -1. So we're going to plot -1, positive 3, 1, 2, 3. So there's 3 good points. And as you can see, it carries down this way and it heads on up this way. So graphing using function notation really hasn't much changed. Just some little logistics here, the way it looks. There's no y, but we have ourselves what's called function notation. All right, so we have 3 graphing review problems with function notation, and that will be the end of the lesson today. Let's take a look at number 5 on your own. Graph 3x minus 2. Again, I'm going to make it very simple for us. I'll try it x equals 0. F at 0 would be 3 times 0, which is 0, minus 2. So that's equals to -2. So that ordered pair, so to speak, would be 0, -2. Okay, so I'll put that one in. And then let's use f at 1. F at 1 is going to be equal to 3 times 1, which is 3, minus 2, which is equal to negative 3 minus 2 is equal to 1, I should say. And that ordered pair would be 1, 1. So go ahead and graph that one. Another ordered pair would be f at 2. Kind of see where the graph is going. So f at 2 would equal 3 times 2, to be 6, minus 2, and that equal 4. So that ordered pair would correspond to 2, 4. And let's go ahead and graph that one. 2, positive 4, 1, 2, 3, 4 would be right there. So the ordered pair is graphed. I got a little crooked, but you get the idea. And that would be the graph of number 5, 3x minus 2. Okay, let's do 2 more graphs and we'll be done for this lesson. Number 6, the negative of x plus 4. So I'm going to start out with f at 0. If I use f at 0, that would be the negative of a 0 plus 4, and that's equal to 4. So your ordered pair would be 0, positive 4. So let's go ahead and graph that one. 1, 2, 3, 4, right there. Another one that would work nice would be f at 1. F at 1 would be equal to the negative of 1, which is negative 1, add 4, and that would be equal to 3. So your ordered pair there would be 1, positive 3. Okay, so let's go ahead and graph that one. 1, positive 3. One more, we'll do f at 2. F at 2 would equal the negative of 2 and then plus 4, which is positive 2. And the ordered pair there would be 2, the x, and a positive 2. 2, 2. And that would correspond right here. So you can see how this graph would go. Through there. So function notation is also used a lot with graphing. Let's do one more example of this. Number 7, h of x is negative 3/4 x minus 1. Okay, so let's be a little choosy on the values of x because I want intersections. I want actual points on the line. I don't want halves and decimals. So let's try to find multiples of 4 that will work. That might be the best. But we can always start with 0. Okay, h at 0 equals negative 3/4 times the 0. Okay, and then subtract 1. This is 0 minus 1 is equal to negative 1. So that would correspond to the ordered pair 0, negative 1. So let's go ahead and graph that first. Right there. 0, negative 1. And I guess I would focus on multiples of 4, like 4 itself. Okay, so let's try that. H at 4. Okay, what that will do is we will be able to cancel the 4. Okay, we'll be able to cancel the 4. And once I cancel the 4, I can subtract my 1. The 4s will cancel. I have negative 3 minus 1 is equal to negative 4. So your answer there would be x is 4, h of 4 is negative 4. 4 and negative 4. So let's go over to 4 and down by negative 4. 1, 2, 3, 4. Place a dot. And the last one for number 7, let's try h of negative 4. Okay, if we use negative 4, again, we'll have a canceling situation, negative 3/4 times, now in this case, not 4 positive, but a negative 4. And then subtract 1. So in this case, the 4s would cancel, but when you multiply, you end up with a positive product. Positive 3 minus 1 equals a positive 2. So our pair there would be negative 4, 2. So I'll plot that one. 1, 2, 3, 4, up 2. So you can see the line form nicely on those 3 dots. We'll connect them up and extend them through. Put our little arrows at the end, showing that we have more solutions than just those. So function notation, it replaces the y, okay? And it's used a lot in environmental studies, environmental engineering, a lot of different jobs. If you carry on with your mathematics, you would use function notation instead of the y, okay? So just keep in mind, it replaces the y. You don't want to think much into this other than it replaces the y. And the rest of it's more or less kind of, it's kind of window dressing, okay? So basically it's a way to show right away what that x is, okay? So that's also what's kind of nice. So you can see if it's f at 2, we already know that x is 2, all right? So remember now, function notation replaces the y. It tells you what that domain is. And the notation is another name for y. And that's all that we have to know on this. And I hopefully you found this beneficial, and we will talk with you soon. Take care now, everybody. Have a good one.